Hi everybody, welcome back to the Feynman technique. Today we're going to be kind of doing a deep dive into this function right here, arctangent of Ix. I'm going to be using this formula in some of my upcoming videos. In fact, I used it in my last video. But I really want to get deep into this function and how it behaves. All right, so first let's derive it. Um, okay, so I start off with this integral from, or just the indefinite integral of 1 over 1 minus x squared. And you can use partial fractions on that and break it up into two separate integrals like this. Um, and then you can evaluate each of these individually, combine them into one natural log, and get this. All right, great. But now, what do we have? Now we have some integral that we can do a u substitution on being equal to this result. So let's make the u substitution. Don't forget, we're doing this u substitution after we've already figured out what the integral is equal to. This is just going to give us something else that is equal to that result. So we're going to let x equal iu. All right, so performing that substitution, we end up with I times the integral of 1 over 1 plus u squared du is equal to this. Of course, that integral is very easy to evaluate. That's just going to evaluate to I arctangent u. Now, notice, and we have to bring this back to the x world. We defined x to be iu, which implies that u is negative ix. So all we do is we plug in our x value. We plug in our x values back in. So now we have I arctangent of negative ix is equal to 1/2 the natural log of 1 plus x over 1 minus x plus c. All right. So now what I did is I brought the negative sign outside of our arctangent function and then divided both sides by negative I right here. And of course, this c is going to absorb any multiplication by a constant. Um, and then I multiply the top and the bottom of this by I to just give us I over 2 instead of negative 1 over 2I. All right. And let's notice that this is going to be good for x, only for x less than 1. Because if x is less than 1, that gives us a negative value inside the natural log, which we don't want. Okay, so we have arctangent ix behaving like this for x, the absolute value of x less than 1. So let's choose a value for x that whose absolute value is less than 1 so we can solve for c. The easiest thing to pick is 0 because then we just end up with 0 being equal to 0 plus c. That means c is equal to 0. So what we have now is this. But I want to know how this behaves for other values of x. So how are we going to do that? Well, what we can do is you'll notice right here, if our x was actually greater than 1, we'd introduce a negative. So let's just go ahead and introduce the negative. Let's just do it. Let's introduce this negative, and then you'll notice I also divided by a negative 1. So I multiplied by negative 1 and divided by negative 1. And I just flipped the 1 minus x to an x minus 1. Okay, and now you'll notice that this term that I have highlighted is going to be good for x greater than 1. All right, now we can use the properties of logarithms to split this up into two separate natural logs. And what we'll end up with is, for our first natural log, we'll have I over 2 times the natural log of negative 1. The natural log of negative 1 is I pi. Multiplying those together would give us negative 2. And then we'd just be left with this. This would be our other natural log. And so this is going to be good for x greater than 1. All right. Now let's go ahead and let's just see what the real and imaginary parts are on this interval. Of course, the real part of arctangent ix is going to be 0 because we're looking at for x absolute value of x less than 1 because it has no real part. So it's just 0. And the real part of the arctangent Ix function is going to be equal to -2 for x greater than 1, because this is going to be, for x greater than 1, this will be a purely real expression, and then multiplied by the imaginary unit will be purely imaginary, so it does not contribute to the real part, so we just have -2. All right, what about the imaginary parts? Well, for the absolute value less than 1, we're taking the imaginary part of this. And for x less than 1, this expression is going to be purely real. So this whole expression is going to be purely imaginary. So the imaginary part of arctangent Ix for absolute value of x less than 1 is 1/2 natural log of 1 plus x over 1 minus x. And finally, to finish this off, the imaginary part of arctangent Ix for x greater than 1 is going to be the, for x greater than 1, this part right here is always going to be real. Therefore, this part is always going to be real. Therefore, the imaginary part is just this, except with 1 instead of I. So the imaginary part is this. All right, guys, that's my deep dive into the behavior of the function arctangent Ix, and I will be referencing this video in future videos. Anyway, hope you enjoyed that, and we'll see you next time.